Hello and welcome to the Chemistry Made Simple podcast. I'm your host, Matthew Macario, and this is the podcast where you get chemistry confident and where I help you to get from point A to grade A. Hello, welcome back. I hope that you're keeping well. In this episode, we're going to be talking about one of the reactions of alkanes, and this is the formation of halogenoalkanes. So in this episode, we'll talk about what is a halogenoalkane, and we'll talk about the mechanism of the reaction of formation of halogenoalkanes. And to do that, we'll define what is a mechanism and we'll define what we mean by free radical, because this is the free radical mechanism that we'll be talking about today. Let's start by talking about what we mean by a halogenoalkane. Simply a compound that is based on an alkane but has a hydrogen substituted by a halogen atom. For example, one of the hydrogen atoms has been substituted by a chlorine atom. And we're going to be talking about the free radical mechanism. So what do we mean by a mechanism to start with? A mechanism is the pathway of the steps that are required to go from our reactants to our products. That doesn't always happen with a simple one-step process. And during your studies of organic chemistry, you will get to learn a few mechanisms. Today we're going to talk about the free radical mechanism, which is the mechanism that takes an alkane to a halogenoalkane. What do we mean by a free radical? In chemistry, a free radical is a chemical species that has an unpaired electron. Free radicals are very reactive. The state of having an unpaired electron is a reactive state. It's not a stable state, and therefore free radicals always want to react to pair up that electron if possible. And therefore free radicals will react to pair up that electron if possible. In the free radical mechanism, we have three main steps. We have a beginning, a middle, and an end. The beginning is called the initiation step. The middle is the propagation step. And the end is the termination step. Let's look at those in more detail. We're going to use an example reaction. We're going to talk about it throughout this mechanism so that we can explain what's happening with the mechanism. We're going to be talking about the reaction between methane and chlorine to produce chloromethane. Okay, let's look at the beginning step, the initiation. In the initiation, we're going to create our free radical to make the reaction be able to start, to initiate. And the free radical that's going to be produced in this example is a chlorine free radical, a chlorine atom. And a chlorine atom is a free radical because in its outer shell it has 7 electrons, and therefore one of those is an unpaired electron, making it a free radical. But we don't just have free radicals of chlorine around in a jar. They tend to be rather reactive, so they don't stay as free radicals for very long, and therefore we need to initiate them at the beginning of this reaction, and they can't be prepared beforehand. So how do we do that? In this reaction, we have chlorine gas, Cl2. And what we must do in order to initiate, to create those free radicals, is we must subject the chlorine to ultraviolet light. And usually we use sunlight. In fact, this type of reaction happens a lot in the upper atmosphere. One of the common questions you'll be asked is about what are the conditions of this reaction, and the answer is that you must have ultraviolet light present. Why does UV light need to be present? Well, UV light or particular wavelengths are going to be exactly the right amount of energy to break the chlorine to chlorine bond, and to break it in such a way that the electrons that are being shared within that bond go one to one atom and one to the other, so that the product is 2 chlorine atoms, 2 chlorine free radicals. So in summary, initiation is required to create the free radical that is going to kick off to start the reaction. So the next step of the reaction is the propagation, and the propagation happens in 2 stages. The first stage is that a chlorine free radical collides with a methane molecule, and the chlorine free radical takes a hydrogen atom from that methane molecule, resulting in a hydrogen chloride HCl molecule being produced. Because it took a hydrogen, it had to break a carbon to hydrogen bond in the methane. And you'll note a hydrogen atom was taken. Therefore, just one of the electrons in that carbon to hydrogen bond was with that atom. That means the other electron in that carbon to hydrogen bond remains with the methane molecule, and that is now an unpaired electron. So the result of the first stage of the propagation is that a CH3 methyl free radical is produced plus a hydrogen chloride molecule. Of course, that methyl free radical is reactive just like any other free radical. So the second step of the propagation process is that methane free radical bumps into another molecule. So it bumps into a molecule of chlorine, Cl2. And there is plenty of Cl2 present because only a small proportion has its bonds broken by the UV light. What happens in this step is that the methyl free radical takes one of the chlorine atoms from the Cl2 molecule, and that results in CH3Cl, chloromethane, a nice stable molecule. But the other product, of course, is what's left over from that Cl2 molecule is another chlorine free radical. So the second step of the propagation has created another chlorine free radical. The first step used a chlorine free radical. The second step creates another chlorine free radical. So this propagation process can go on and on as the chlorine free radicals are used and regenerated in that two-stage propagation process. Because the chlorine free radicals will just keep reacting with the molecules they collide with. The free radical mechanism is often referred to as a chain reaction. But it does come to an end at some point. So the termination happens when two free radicals bump into each other, collide with each other, and react. Why is that the end point? Because both have an unpaired electron, which they put into a bond. There is no free radical product to that reaction. Therefore, that terminates the process. There's no free radical product to continue or propagate the reaction. It's terminated. So what free radicals might we have that might bump into each other? In that mixture, we have some chlorine free radicals. So two chlorine free radicals may collide with each other and react and form a Cl2 molecule. We also talked about methyl free radicals, CH3 free radicals. Two of those may collide with each other and form C2H6, ethane. And of course, ethane is not a free radical, it's a nice stable molecule. Another possibility is that a chlorine free radical and a methyl free radical may collide with each other. And that's another way that chloromethane will be formed in this reaction as a stable compound, but it's a step where there is no free radical formed and therefore is within the termination step of the reaction. Be careful to note that this is not the main way of making chloromethane in that reaction. The vast majority of the chloromethane formed happens in the propagation step when a chlorine free radical and a methane molecule collide with each other and another free radical is produced as one of the products. So what products might we get from this overall reaction? We mentioned that we get chloromethane. We mentioned that ethane is one of the products from the termination step. We also mentioned that we can get chlorine reformed. That's one of the reactants, so we don't necessarily consider that to be a product as well. We also get some additional reactions happening. So that propagation step, let's think about that. In that propagation step, a chlorine free radical might bump into a chloromethane that's already been made in the reaction. And actually, the chlorine free radical will react with that too. It will pinch a hydrogen. So we would end up with a chloromethyl free radical. And eventually, we'll go on to collide with another chlorine molecule. And the product of that would be dichloromethane. In fact, the dichloromethane can go on and bump into a chlorine free radical. And that process can continue and continue until all the hydrogens of the alkane are replaced with chlorines. We could have chloromethane, dichloromethane, trichloromethane, and tetrachloromethane amongst the products. We also mentioned that one of the products formed in termination is ethane, and there's no reason why ethane might then go on and bump into a chlorine free radical. And the product would be chloroethane. And following on from what I said a moment ago, further iterations of the propagation step could lead to products such as dichloroethane and so on. And for some molecules, that will continue until all the hydrogens are substituted in the ethane molecule. So there are a number of additional products that we get. Well, we'll consider the main product as the chloromethane that results from one iteration of the propagation step. But there are a multitude of other possibilities where further reactions of the propagation step of that chain reaction occur. Okay, let's quickly summarize. We said that a mechanism is a pathway of small steps to get from a set of reactants to a set of products. We said that free radicals are chemical species that have an unpaired electron. For example, the chlorine atom and the methyl free radical that we talked about. We said that the free radical mechanism has a beginning, a middle, and an end stage, the beginning being the initiation, where the chlorine free radicals are produced, and that is merely by UV light cleaving the bond in a Cl2 chlorine molecule. We said there's a propagation step that is in 2 stages, where that chlorine free radical reacts with the alkane to produce an alkane free radical, and that alkane free radical then reacts with a chlorine molecule to form the chloroalkane. Overall, on those 2 steps, we start with a chlorine free radical and we produce another chlorine free radical, so it regenerates itself, and therefore the propagation stage is a chain reaction. We talked about the end step, the termination. That happens where 2 free radicals collide with each other and produce a stable molecule and no free radical product. Okay, so if you have any questions about what we've talked about today, the best place to raise those with me is in the show's Patreon community. So if you're already a member, ask away there and I'll be answering those questions. If you're not a member yet, you can become a member for the price of about a cup of coffee a month. And all you need to do is go to patreon.com/chemistrymadesimple and sign up. It's really easy. And I'll put that link in the show notes. You can also get in touch with me on Instagram at Chemistry Made Simple or email matthew@chemistrymadesimple.net, and I'll put those in the show notes too. So this has been one of our deeper episodes, and I'm fully expecting to hear those questions coming in. Also, please do get in touch and tell me what takeaways you got from this. I do love to hear that feedback too. All that's left for me to say is that I look forward to speaking to you during the next episode. Until then, do look after yourself and goodbye.